All right. All right. So thanks everybody for inviting me to give this talk. Just a bit about me. I'm a principal software engineer at Anaconda. Most of my work involves packaging, conda and conda build, and basically getting bits on computers. I'm kind of privileged and I get to work on open source I'm paid to work on open source for tools I use. So I'm working on Conda and CondaFront and kind of the associated ecosystem. I'm also a member of the CondaForge core team, and my professional background is mostly in scientific and high performance computing for life sciences, mostly in genomics. I'm obligated to say that Anaconda is hiring. Our careers page are probably, I think, 30 open positions at the moment. But moving on. The work I'm going to present here is really a collaboration between a number of people. From the Anaconda side, we have Giannis and Bianca and Dave. From Quant side, who's one of our partner companies, Jaime and Felipe, and then QuantStat, Wolf, and then obviously all our open source contributors. All right. So what am I going to talk about today? First, I'm not assuming anybody knows what Conda is. So I'm just going to give you a brief introduction to what Conda is and what it does. I'll talk about the ecosystem as a whole and how it's grown in the last few years. And then I'll introduce sort of one of the biggest problems we've seen in Conda, particularly around performance and how we fix that. And then I'll wrap up talking about some of the lessons we learned or relearned in sustaining a large open source project. All right, so kick off on what Conda is. First of all, what Conda is not. Conda is not a synonym for Anaconda Inc. This just happens to be maybe a branding carryover from how Anaconda started as Continuum.io and grew up to change names as a company. But again, Conda is a completely separate thing for Anaconda, the company. All right, so what's Conda? Conda is an open source, cross-platform, language-agnostic binary package and environment manager. Breaking it down, cross-platform means we support major operating systems, Linux, Mac OS, Windows. We support a broad range of hardware, ranging from Raspberry Pis, single board computers kind of thing, to your standard laptop and desktop, all the way up to fairly large IBM mainframes, to honestly like large supercomputing centers. We're continually adding platforms. So, and again, as open source, if you want to add a platform, just open an issue on GitHub and we'll help you get there. Language agnostic. So Conda, by and large, is written in Python, but it is not a Python package manager. It's more of a general purpose tool. So it's not limited to things that are developed in Python. We support R, Perl, C and C++, Rust, Go. There's a VHDL Conda package for some reason. So you can do your FPGA programming with Conda. Conda packages, and even though Anaconda is mostly known on the data science and machine learning AI space, again, the ecosystem itself is much broader than this particular vertical. Binary package, by that we mean generally Conda packages are pre-built, ready to install software. So for a lot of open source tools, it means you don't have to get a compiler, you don't have to figure out how to build the thing from source. And then as an environment manager, we basically provide you mechanisms to create separate self-contained locations for packages you request and along with all their dependencies. So if you're familiar with virtual env of VMs, it's a very analogous tool. So obviously as a package manager, we provide basic commands, right? We conda create, conda removed for creating and removing environments. We have an activate command to switch between environments, and then there's install and uninstall to install packages and manage packages within specific environments. Conda is also an ecosystem, right? We have a number of related tools that I'll touch upon towards the end of the talk, and then more importantly, we have a number of package repositories, which Conda calls channels. So channels are basically where you as a Conda user get your packages. Initially, when Conda was launched in 2022, there was a channel called back then Free and Pro. It's now been renamed to defaults that are Anaconda maintained packages. But since our launch in 2022, we've seen a growth in sort of the open source and other package maintainers. One of the largest ones is CondaForge, and it's community maintained, even though, again, some of us on Anaconda employees are also contributing to these other open source projects. And then we have some domain specific channels as well. So Bioconda is one of the larger ones. It's all sorts of bioinformatics and computational biology tooling. And then other projects like PyTorch, for example, maintain their own Conda packages. And one thing as we go along to keep in mind is Conda environments can pull packages from any number of channels. So if you're familiar with Linux package managers, for example, or with Homebrew, generally with those, or even pip really, with those package managers, your packages are coming from a single source. And especially for Linux distributions, it's a single source with a single set of versions, and that has some implications for what I'm going to talk about next, which is how we support our ecosystem. Conda has been wildly successful, and honestly, when Anaconda started, when Peter and Travis started Anaconda back in 2012, they didn't really set out to create a package manager and a package ecosystem, right? Conda was created to solve a very specific problem they had in mind when they started the company, which was we just need to be able to deliver pre-built Python packages across a lot of platforms. But since then, it was been open source, and again, with a lot of community contributions, it's basically democratized access to scientific software and data science software, and a lot of tooling that, because of its kind of cross-platform language agnostic nature. Along those lines, it's also become a tool for reproducible data science and other kind of reproducible environments, which makes it valuable for teams and collaborative projects. And then for package maintainers, we've created an ecosystem where essentially anybody can contribute a package. And to give you some sense of the scale, when Anaconda launched its first package repository, it was 4 platforms and maybe a few hundred packages. And now with just the CondaForge channel alone, we have something on the order of 900,000 distinct artifacts. It's about 5 terabytes of storage. We serve 27 million users, which equates to about 1.4 petabytes of package traffic per month. But as the ecosystem has grown, there have obviously been kind of challenges that we've seen, largely around performance, which is where I'll focus the first part of the talk, but there have also been sort of issues that I'll touch upon with governance and extensibility, and that has to do with how Conda is or is not an open source ecosystem, and then with user experience that I won't cover in this talk. So to start, like the biggest problem that Conda has seen is honestly the growth of the package repositories. Packages are the key to Conda's success. I've been iterating on or repeating, right? The big thing is we have a promise of reproducibility, which means we don't really ever remove a package from key repositories. So Anaconda's repositories, CondaForge, Bioconda, once a package has been published to that repository, it's basically always accessible. Obviously, since we've launched this, new projects have joined, CondaForge, Bioconda, Intel, NVIDIA have their own channels. We're seeing PyTorch, Microsoft has launched their own channel with new upstream and releases. We've built new versions, we've built new variants. So different versions of packages like NumPy with slightly different feature sets. And to keep up with that, there have been challenges like maintenance costs, maintenance of the code base, paying for the infrastructure. 1.4 petabytes of traffic is not cheap, and then performance challenges. Again, to give you a side, this is as of earlier this afternoon. Anaconda itself provides something on the order of 9,500 package namespaces. So Python would be a package namespace, NumPy would be a separate one. That corresponds to about 167,000-ish distinct package artifacts. It's about half a terabyte if you kind of collected it all up. CondaForge, as I mentioned, is roughly about 18,000 package namespaces, 900,000 plus artifacts, 5.5 terabytes, and then Bioconda, which is again another large community one, is about 9,000 namespaces, 118,000 distinct artifacts, and actually 554 gigs, not terabytes. But the success of and the growth of the ecosystem is also kind of the cause of some of the biggest failures of Conda. So if you go look at our GitHub page, one of the biggest complaints Conda has seen is Conda is getting slower and slower and slower. So to dig into that, let's consider what actually happens when you conda install something, right? When you say conda activate to start an environment and then you install a package in the environment, what does conda actually do? First, there's some shell things it has to do to set up an environment, then it parses the arguments, creates a Python context object that basically generates information about the environment and sort of your local configuration. And then from there, it passes it into sort of the Python guts of Conda, right? So there's user arguments and context. Conda goes out to the channels that you've configured. So those package repository gets a list of those packages. Then it kind of generates a plan for what it should do with relative to instructions. So you want to install NumPy, right? So to install NumPy in this environment, what does it have to install? So NumPy, Python, probably a BLAS library somewhere. And with Python, then there are other dependencies of Python like OpenSSL. So it kind of has to figure out, given the current state of the environment, what needs to change to install NumPy, right? And generates a plan that internally in Conda is called the transaction plan. And then once it has that plan, it actually goes and executes that transactions, which means downloading the packages, extracting them if needed, making sure the packages are actually what they say they are. And then it'll add the files from the package, remove old files, and things like that. And then certain packages can do things like add start menu items on Windows. So there are a bunch of other things that packages can do. From the user perspective, a lot of this is actually hidden, right? That massive solve step, unless it fails, is generally 2-line. I'm collecting the package metadata, and then I'm solving the environment. Then the transaction is basically, here's what I'm going to download, what I'm going to install, and then basically 3 lines to execute all those commands. And really where most of the problems occur, those performance problems, are in the solver step. So these 2 lines, if all goes well. So what does the solver do? The solver takes what we call a MatchSpecs. So it's a language for expressing what you as a user want, right? So NumPy 1.21, some version of NumPy 1.21. And it converts it into a list of package records, which are essentially instances that specify, NumPy 1.21.2 for Python 3.7 build 0 from the Anaconda repository for this platform. The other package records it may contain, for example, to add and remove them if needed. But generally what it does is it takes a user expressed constraint and converts it into a record for like the packages it needs to actually deal with in the environment. So where do each MatchSpecs come from? They generally start as user requested things, right? So I want TensorFlow 2.6. And then from the package index, it pulls out what else is needed to, in this case, install TensorFlow. So a bunch of C++ libraries, H5Py, ICU, JPEG, Keras. I think this thing is something like 25 packages with version constraints for TensorFlow 2.6 as Anaconda builds it. Like, there are these version constraints that are needed in that environment. But really, where do they come from? So yeah, it comes from your original request as a user, but Conda actually needs to be aware of a lot of other things. So looking in your install location, it already needs to be aware of what's already there, right? Are there any packages there that you've pinned? So if, for example, you've told Conda to never upgrade this version of NumPy, what the solver will now have to do is, when you request TensorFlow 2.6, is find a compatible version, a build of TensorFlow 2.6 that links to that pinned version of NumPy. And then there are just a number of other things, right? Conda considers history, which I'll get to later on. So what have you installed in the past in the environment? There are ways to tell Conda to aggressively update certain things. So these are things like OpenSSL and other security critical packages. There are things called virtual packages, which are things that are not Conda packages, but are generally picked up from your local install. So these would be things like if you're using GPU compute, for example, what version of the CUDA drivers you have installed. And then just a bunch of other things. The dependencies I mentioned, updates, kind of tweak some of the matchback behavior. So there's actually, you start with conda install NumPy 121 TensorFlow, and conda-solver has to pull up a bunch of other things to generate the actual list of matchbacks for what it's trying to do. And then less complex is just grabbing all the data you've said and all the channels you've configured and just generating a list of all the package records, candidate package records. With that, conda-solver now has a set of matchbacks that it's trying to do, trying to get as a set of package records. And then this thing happens. So looks complicated, but for the purposes of this talk, what we really need to focus on are these two steps, right? Generating clauses and something called PyCosat that I'll get to. Fundamentally, computing a transaction and dependency management in general. So it's not just conda, it's your RPM and apt, pip. What they're trying to solve is some variant of what's called the Boolean satisfiability problem. And that's essentially a set of Boolean clauses that you're trying to find a solution to make that set of clauses true. Unfortunately, the SAT problem is known to be NP complete, which is a class of extremely difficult problems in computer science for which really no efficient algorithms exist, right? And worse, they scale very, very poorly with the number of inputs. So generally for n inputs to a SAT problem, it scales something on the order of 2 to the n for the number of clauses. So that's not a great thing to try to solve. So what I'll call the classic solver, which is the solver that existed in previous versions of conda, there are a number of heuristics for most NP hard, NP complete problems that you can apply for quote unquote practical cases. And that's the approach that conda takes, or conda's classic solver takes. So we can do a number of things where we, for example, will prune what's available because we know, for example, if you're in a Python 3 environment, like we can prune out all the 2.7 packages from the solution space. And then there are other ways, kind of heuristics that we have built into the conda solver that anticipate and relax potential conflicts and relax some of the constraints, and that dramatically decreases the number of clauses in your SAT problem. And then it feeds it to a SAT solver, and hopefully that works. And if it doesn't, it comes back and redoes all of these processes. And then in the back end, the actual SAT solving part is driven by a package called PyCosat, which is a Python wrapper around a C library called picosat, which is just a general SAT solver. And in order to interface with this picosat library, what we have to do is convert the matchspec and package records into a set of SAT clauses. In the previous version, or the classic solver, this is done in Python. And one thing we discovered in the project I'm about to describe is because we do this in Python, we ended up allocating a lot of Python objects. And allocating Python objects when you have to solve something like SAT turns out to be incredibly, incredibly costly. There's a performance overhead you pay both in memory and runtime for every object you have to allocate. And with SAT solvers, you get a set of solutions back. And then within Python itself, we manage in Conda to make repeated calls to select a quote unquote best solution. And one thing I wanted to point out here is how much of this was done in Python, right? Conda started as a mostly Python project, so most of the work was done in Python. And most of the optimizations up to a point we were trying to do in Python. So what changed? So in 2020, a company called QuantStack made an announcement for a project they had started called Mamba, which is a fully compatible drop-in replacement from Conda. It was driven largely by trying to help us improve or help the community work on the performance issues in Conda in terms of speed and memory usage. And what does Mamba do differently? One of the big things is Mamba is largely in C++. It uses a different SAT solver, libsolve, which is what OpenSUSE and Red Hat use for the RPM package manager, and it avoids a number of legacy behaviors or behaviors that the Mamba team thought people really didn't care about anymore. And it turns out, yeah, if you do these things, it's a much, much faster solver. Something like 1 or 2 orders of magnitude faster solves for some complicated cases. Problem solved, right? We have Mamba. Why didn't the ecosystem switch as a whole? One of it is user inertia. Even today, 2 years on, I think the Conda to Mamba user ratio is something like 10 to 1. Because Mamba took liberties or kind of made different assumptions about what users wanted. There's subtle behavior differences for certain kinds of solves. And then for a lot of users, there was sort of a stability versus innovation trade-off, right? Like Mamba was a new project. Conda at that point was 9 years old. And so Conda was slow, but tested. Mamba was faster, but there was kind of weird corner cases that would cause it to crash. However, Conda still needed a performance solver. Conda itself, the package manager, needed a performance solver. So in 2021, Anaconda and QuantSight partnered to enable libmamba, which is sort of the core library for Mamba, to figure out how to use Mamba as an alternative solver. So basically, sort of a way to unfork the ecosystem. And as of March of this year, we finally got this done. We released it as a currently labeled experimental feature in Conda 4.12. And architecturally, it's really not that different from what Mamba does, right? Mamba builds on libmamba, which builds on libsolve. For Conda, we had to insert this conda-libmamba-solver package as sort of a shim because Mamba and Conda internally have slightly different data representations. But effectively, we now have a shim to allow Conda to essentially use the same solver as Mamba. Experimental feature, but installation is pretty easy. You update your Conda installation. You install the conda-libmamba-solver, which is available both in the Anaconda and Conda Forge repositories. And for now, you have to explicitly pass an experimental solver flag to your Conda create a Conda install commands. But with conda-libmamba-solver, what this gives you is significantly faster solves. But one of the other pieces of work that Anaconda and QuantSight worked on is we tried to put back a lot of the classic behavior. So at this point, I think for a lot of the classic behaviors tested in our integration suite, so the complex solves the use cases that we've seen over history, I think 95% plus are now passing. So some of the old behavior that Mamba dropped has actually been put back in the conda-libmamba solver. So as a demo use case, I ran this earlier this afternoon. Conda solve installing SciPy and TensorFlow with the classic solver took about a minute. Using the libmamba solver, we're now down to 11 seconds. And for more representative timings, if you look at our integration test suite that I mentioned, we're 1.5 to almost 2 times faster than what with libmamba than we were with classic solver. Because we have a faster solver now, there are a number of changes within the internal logic of these two backend solvers. A lot of the things that shortcuts that we took or heuristics that we applied in the classic solver are gone. We no longer have to do index pruning. We no longer have to anticipate some of these conflicts or other constraints that we think about working around in a classic solver. We basically can just go grab the index of packages and just run the solve. Sort of some of the internal differences to mention. The big one is because we now have switched to C and C++ on the back end, a lot of that costly overhead in maintaining Python objects is gone. The storage efficiency has gone up, and the memory and the performance has improved significantly, just because we have a more efficient way of managing these objects. There are, again, we've tried to replicate as much of the old behavior, but there may be some cases that are still different. And then one of the big things that, in addition to performance, that we've had complaints about is conda has generally, for a lot of complicated solves, has not given great messages. So if it can't figure out why something, if it can't find a solution, conda in the past didn't give great suggestions about what you should try next. And with Mamba, that has improved somewhat. And more importantly, if it gives you unhelpful error messages, at least it gives you unhelpful error messages much faster. So for all the conda users out there, we really encourage you, like I said, this has been out there for a few months now. We worked out most of the critical stability bugs, but we would love for you to try this feature and then just report it to us if you run into any issues. And planned enhancement is currently there are a couple of conda built integration things that we need to work through. That should be released within the next month or so. Because this is an experimental feature, there are some limitations we originally imposed. For example, we didn't allow you to mix the classic and new solver in environments, and in particular, we didn't allow you to use the libmamba solver in your base environment. That's going to be removed in the next release or two. And then looking forward, I think, we are now confident enough that we're going to clearly remove the experimental flag at some point and probably make libmamba the default solver. And I think one of the other things that we learned in this project that I want to talk about now is some of the other challenges about managing a large, kind of very disparate open source ecosystem, and particularly around governance and extensibility of sort of your core tooling, right? So if you go on GitHub, and there are a lot of tools that are based on conda, a lot of tools, some of which we weren't even aware of until we tried to generate this word cloud. But sustaining this number of tools and the number of users that we see takes work, right? We want to make sure that all stakeholders are heard, and we want to make sure that contributing to not just conda, but the broader ecosystem is easy and sustainable. And two of the challenges we identified in this project are a kind of sociological. There's one key sociological problem and one key technological one. The sociological one is the perception of Anaconda as a semi to non-responsive, possibly benevolent dictator for life. So a lot of the community felt left out of decision making, right? There wasn't clear where Anaconda was going to take conda as a project. And so if you were non-Anaconda contributor to conda itself, or all the tooling around it, you never really know where the ecosystem was going to go, because the core tool was managed by Anaconda. The technological one is, again, because we didn't really set out to create a package manager. The growth of the code base was sort of organic. When we saw an issue, we found the fastest PR, the fastest fix to get to solve that issue and then released it. And that led to a very complex, monolithic, and honestly quite fragile code base. So one of the, I mean, since honestly, since 2012, like when Conda first launched, like there've been a number of attempts to fix the conda solver itself prior to Mamba creating this pseudo fork. And it turns out because of these two issues, these two challenges, one, it was very hard to get Anaconda to respond to PRs, so to evaluate PRs. And then two, even if you got PRs in, it would just randomly break things in the code base. And so prior to 2020, 2021, Conda, for a lot of people, felt more open source in name than in actual practice. And so what are we doing to improve that? The first one is we are purposely handing over control, we being Anaconda, are handing over control to a multi-stakeholder steering council. We are structuring a new steering council where Anaconda gets a certain number of votes, but not a controlling number. And what we want to do is make sure that both commercial and open source, non-commercial volunteer efforts get a voice in how Conda as an ecosystem and as a project get votes and a voice in where this project is going. We've also formalized an enhancement process based, if you're familiar with the Python enhancement proposals or the NumPy enhancement proposals, we formalized a similar process for SEPT, Conda enhancement proposals to gain community input. And here are a number of SEPs that are open. We actually have an open vote now for a new feature in Conda that's coming out. And then there are a number of other SEPs that are out, largely around what versions of Python we're going to support and a kind of a deprecation policy. And then we've also created we and a number of other community partners have created a Conda incubator GitHub organization. And the goal here is, if you remember that giant word cloud of all these Conda related tooling, it was really hard to discover what was there if you were a user unless you sort of stumbled across it. And the point of the Conda incubator is to start projects in the ecosystem, and then as they mature, get to a level of maturity, they will get promoted into sort of the main Conda organization. So, dog fooding our own practices, like the conda-libmamba-solver as an experimental project is still in Conda incubator. And as it matures and gets to a point where we're confident in releasing as production software, it'll get promoted to the core Conda repository. On the extensibility front, yeah, sure. Let's go do simple things. Let's just go prune out that code. There's a bunch of Python 2.7 code in there that we'll never need again. We'll just refactor for tech debt. We'll just make things more modular, which sounds easy. A lot of work, but quote, easy. Except for something called Hiram's Law, which is with a sufficient number of users, and Conda has 27 million odd users, it doesn't matter what we promise in the API. We can mark things as private. We can mark things as deprecated. All of these behaviors will be depended upon by someone, right? And it's very easy for us to engage in those practices like refactoring or removing that code and accidentally break Conda or some other critical Conda tool for someone. So for example, with the last release, we removed a Conda Python 2.7 shim and accidentally broke Conda build because there was just a random code path and a random thing that Conda build happened to be depending upon. That was not a published API. So because of this, it's really hard to figure out how you can safely, with the complexity of the Conda code base, like how you can safely change something. And to do that, one of the things we've also done recently is we've now defined a new plugin-based version of Vision for Conda, right? I think the goal here for this is to start minimizing and working towards minimizing what's in the core code base, and then replacing a lot of those complexity and internal behaviors with a well-defined API. There are a set of published API hooks for a number of things. So we want to convert our digs, both the classic solver and libmamba, to actually be plugins and not things that have code sprawl within internal to Conda. A lot of Conda subcommands and things like Conda build and Conda lock and Conda project. These sort of tools should be integrated as plugins rather than, again, adding various other hooks into the core Conda code base. Integrations with various shells. The virtual packages are now kind of sort of hard coded into Conda. Support for shells like Bash and C shell and PowerShell are hard coded in Conda, and we want to find ways to extract those. Authentication against package repositories, again, hard coded behavior. We want to take that out. Caching, IO, and who knows what else. And again, the goal here is to expand Conda as a project and as an ecosystem, right? It's to give, by minimizing what's in the core code base, we want to allow people to explore new ways of using Conda, so that Conda can be used for more than how do I install TensorFlow on Windows, to help balance this trade-off between stability and innovation. So providing a clearer path for maintainers like the Mamba team to find ways to hook back into Conda more directly. And then from there, looking at how IPython, for example, converted to this more modular plugin-esque architecture, like what else, looking at new chapters and having the community find new chapters for Conda as a project and as an ecosystem. And with that, I'm going to wrap up, and I'm happy to take any questions.
I'll start with one, if it's okay. So first of all, thank you for this. I didn't know so many developments happened in the last several years, so this is nice to know, especially the governance one. I was curious and amazed, so thank you for this. But as for questions, I recently encountered people who want to build a package. Just one of the, I wanted to give them some simple like link to or tutorial on how to build a Conda package. Do you have something recommended? Because eventually it's a package builder. If someone wants to build their own package, how do they build a Conda package? Do you have tutorials around it, videos, or something that you recommend following?
Yes, I will have to dig them up. I think both the Conda build documentation has some simple tutorials, and then Conda Forge has tutorials a little bit focused on their CI system, but the parts of it, if you just want to build it locally, you can still apply. Basically, as long as you don't open a PR in the stage recipes or an existing feedstock, you can use the Conda Forge tutorials to build a package locally, or for any other package channel.
Okay, so I knew things for myself from many years ago, and things have changed, but I'm just looking for recent. So thank you for this. I'll look at the Conda Forge tutorials. Thank you.
Yeah. Yes.
And at the same time, the question: if someone has a question, do you still have the Conda mailing list, or who to contact if someone who has Conda questions?
We do have the Conda mailing list. Conda.slack.com is now a thing, so you can go there. And then part of this governance change too is we're working with Conda Forge and BioConda and a number of other partners to community members and partners. We're trying to figure out a way to build sort of a landing page to properly direct people to the right place to ask for help. A lot of what we're seeing is people don't quite know where to land for help, or there's not a clear landing page for help. So you'll see things like, oh, there's a bug in Conda reported to some random feedstock on CondaForge, or there's a misbuild on this CondaForge package being reported to the kind of the core Conda issue tracker. And so I think one of the things that we're working towards building as well is, because of, again, this ecosystem that's grown up, Googling how to report a Conda issue doesn't always land you in the right place. And I think that's one of the things we need to work on as a community.
Okay.
Yeah, looking at the chat, hat tip on SKR. Yes, that is the Mamba team. Our demo how to write a plugin is actually how to write a Conda plugin that takes anything you put in a command and turn it into ASCII art. Non-breaking change, but at least demos how to write a plugin. That should be merged into the mainline branch pretty soon. Me, just curious, what your take on API contracts is. Complicated. I like them as a developer, but again, Hiram's law, and especially with Python, where you don't really get kind of visibility controls other than please don't call anything that starts with an underscore or a dunder function. I think they're good in the sense of establishing sort of boundaries. This is what we promise to give you, and this is how long we promise to support it. I think in practice, it's a lot more complicated because, again, if you expose it, and particularly with open source software, I think in my experience is once you expose it into code, somebody somewhere will depend on it. You know, I think one of my favorite examples about API contracts is the Windows API, for example, has very specific guidelines about, for example, how to manage memory. There are still shims in Windows because SimCity 2000 did not follow that API contract, and now Windows must forever have that bizarre shim so that SimCity does not break on Windows. So yeah, useful in principle, much more complicated in to manage in practice. Does Anaconda play well with virtual env? Not really. I would not recommend virtual env and using conda and virtual env together. Conda and pip is a little bit more of a complicated story. When you first create your environment, conda and pip, I would say, kind of mostly work okay. You can create a conda environment and then pip install something, and that mostly works okay. But once you have to update something, that's where this conda and pip interaction will break. It is an issue in our backlog. It's something we're very interested in fixing. And especially building support for being able to conda install wheels directly. And really, the challenge here is, the major challenge that we have is conda and pip have very different ways of keeping track of what's actually in the environment. And in particular, because conda, as I mentioned, is language agnostic and domain agnostic for the most part, in a conda environment, you can have a lot more things that pip just won't be aware of, but there's a chance if you pip install or pip upgrade something, you will break. Just because if it's a non-Python package, pip is just not going to be aware of it. That's something we're actually actively working on improving. So what we actually just conda create the environment. There's really not a reason to create a virtual env, kind of the Python virtual env within a conda environment, or vice versa, a conda environment within a Python virtual env. But for the most part, there's a one-to-one mapping between, well, generally, if you can create it in virtual env, you can come back and create it in conda. There may be some remapping of the package names you're going to have to do, but generally you can take your virtual env specification file and build a conda environment out of it. And worst case, you can really, there's a mechanism, and again, I can point to the documentation after the fact, to essentially just create a conda environment with the version of Python you want, and then pip install the rest of it. And again, as long as you don't update the Python interpreter in that conda environment, you should generally be okay.
So we've been talking about like conda and pip and virtual env. Can I ask you just like a really basic question? So say I'm somebody who's new to Python, people are telling me we should pip install this or conda install that, or use pipend or use poetry. Could you give just like a little 5-minute rundown on what these things are?
Really, only 5 minutes?
It's challenging.
I got on the XKCD. They're all essentially ways of delivering bits onto your computer, right? Like, I think with setup tools and disutils and pip and virtual env, I mean, they're just evolving ways of how the Python ecosystem as a whole has thought about delivering packages. And they're just kind of iteration. I would just, to summarize, I would just say they're iterations on this. At the end of the day, I think pip, virtual env, and poetry, PyProject, they're all roughly converging out. They're just different ways of expressing certain things you want in your environment, and sort of I'm going to stop sharing my screen real quick. I'm biased. I'm just going to say use conda because I'm a core dev. I'm just, in my experience, the reason I use conda is because I will inevitably need something that's not Python. And I just found it easier if I'm trying to build data science or analytics workflows. If I need something that's not Python, it's just easier to deal with all of that in a conda environment. If you're fairly confident you're going to just be using Python, I honestly pick what your collaborators are using is what I'm going to say. I will say if you're starting a new project, so if you're starting a new Python package, go the PyProject TOML route. Like just use the newer version. Definitely don't use disutils because that's about to disappear. But again, pick what your collaborators are comfortable with. Yeah, does that kind of cover your question?
Sure. So there are ways of getting bits onto your computer. And I appreciate you giving, the caveat and being upfront about your bias here, being on the core team. I also think it's okay to be proud of something you built. So if I was someone who was trying to pitch conda and using conda for installing packages as opposed to using something like pip or poetry, and you alluded to this a little bit that if it's anything that's not Python, you really need it. Could you go into a little bit more detail about like, why can't I install something that's written in C using pip?
I mean, in principle, you can't, right? So let me take the example of JQ. So modern web APIs, a lot of stuff comes through as JSON, right? And in the projects I work on, like I like using JQ to do the processing on JSON because Python JSON processors are slow and JQ has some nice features. So if I'm using virtual env, for example, I can virtual env create and pip install my Py data stack, right? NumPy and SciPy. Now I want to go install JQ. My options are, if I'm on a Linux distribution, I can, well, if I have super user privileges, I can apt install or yum install or DNF install JQ and get the system version, and hopefully that works. If I don't have super user privileges, then you're kind of in a bind, right? Like if you want to install it and make it available, you can either go download a pre-built version from somewhere with all that entails, or you can go to GitHub and download the JQ sources, and then, hopefully you have enough of the system compilers installed to do configure, make install to your local prefix. So yeah, you can go out and download and build this thing and then put it in your virtual env in the bin directory. That's a lot of work. And if you're on Windows and you want to use the same, you want to use the same tooling, that becomes way more complicated, right? If you're an open source contributor, okay, I mean, at least Visual C is now available for open source users to use for free. JQ, I can tell you, does not build directly with Visual C. You do have to go build a lot of Unix shims. So now you have to go figure out how to use MSys2 and link that with Visual C. And then you got to figure out, okay, how do I install Python on Windows, which can be done. Pip on Windows and virtual env on Windows is not as smooth an experience in my as on Linux or Mac OS. So yeah, I think can you replicate a lot of what Conda and its ecosystem deliver? The answer is yes, because nothing we do in that ecosystem is secret. Like, you can go to the feedstock and figure out how to literally copy that shell script, and with some work replicate what's in the Conda package. But is that your day job? Is that what you want to be doing? Right. And I think the other sell for Conda has been and this is partly my bias, and it's also from the users that we talk to, is it's not safe to always assume that the people you're working with are on the same platform as you, right? If you have to share your environment, your compute environment, or how to construct your compute environment across platforms, again, it can be done, but I think it's a lot easier with Conda, right? And the use cases that we heard, like a very common use case that we hear is, I'm a data scientist, I'm developing my workflow on Windows, and I have to deploy it to production. And I have to make sure I get the same versions of Python and NumPy and SciPy and TensorFlow on my production Linux server. And with Conda, you can export the environment in a way that you can go and Conda create those set of at least that versions, not necessarily the same build because they're different, different operating systems and different architectures, but you could at least capture the stability of the versions, right? From your Windows dev box to your Linux production box. And again, can you do this without the open source tool? And the answer is yeah. But I think from my experience and from our user base's experience, it's a lot more difficult, and it's not something they want to deal with. That said, WSL2 and Docker on Windows may sort of kind of change the story, maybe. I don't think so, but I think there are other things that Conda provides. But yeah, in principle, you could run Linux workloads in WSL2 and Docker and maybe recreate the container in Linux. Performance, if you have to do I/O, will be really bad. I'll say that much, but it's doable.
Yeah, thank you for that answer. I think those are two really good points. I've had this experience, I'm sure a lot of other people have too, where you're trying to just like plot something on a map, and for whatever reason that means like installing, proj or gdal, and you spend half a day just trying to get the thing to compile on your computer, and you sort of like give up and walk away. And one of the things that Conda does is you can just Conda install whatever, and it brings in the already compiled packages. It all links them up correctly, and it's a 1-minute thing instead of a whole day endeavor.
Yeah, I would never wish building GDAL from source on anyone. Having been the maintainer of that Conda package, I would not wish that upon anyone. Yeah, I think that, again, like, a lot of the package, like if you go to PyPI, right, if you have a Python package that depends on GDAL, a lot of the wheels already will capture it, right? There are ways and wheels to at least provide some version of GDAL. I think the problem is back to that. How do you ensure that everything that you use, like be it Python packages or non-Python packages, like how do you know they're all using the same version of GDAL? Again, with non-Conda tooling, it's possible, but it gets complicated. I think with Conda and reasonably well-maintained repositories, you can at least, so CondaForge and Anaconda's repositories, you at least stand some hope if all your tools will either use that same version of GDAL, or Conda will come back and tell you that no such solution exists, right? And I think one of the other interesting things with Conda, one of the commands I didn't talk about is conda run, which allows you to run specific executables within the context of different environments, different Conda environments. So, you can, in theory, do, if you have legacy Python 2.7 code, right? You can, in theory, conda run that script, and using sort of the Unix philosophy of tools that do one thing and does it well, and everything is a file, including standard in and standard out. Things I've done is I have a legacy Python 2.7 script. I'm going to do conda run -n, Py 2.7 that script, pipe to conda run -n my Py 3.9 script, and it will work for the most part. So I think there are things like that Conda enables that would probably be a little bit more complicated to do something like virtual length. And to set some context, like I was not an Anaconda when it was founded. I've only been at Anaconda for about 2 years. I've been in the ecosystem much longer. And the reason I got into the ecosystem was largely that I need stuff that's not exclusively Python or not exclusively R, and I need a repeatable way of constructing those environments. That was the hook for me, and that's kind of what I evangelize. Right.
Awesome. Thank you so much for that description. Does anyone else have questions for our speaker? Here in the chat, Zvi is asking, can you compare or contrast with ASDF, which I think is what I type on the keyboard when I'm mad about something?
No, because I'm not familiar
No.
with ASDF, but now I'm going to go look it up.
Could you like recommend any good first issues for people who do want to contribute? Like
Documentation.
maybe they're starting out.
Yeah, documentation is a good one.
Like in what way? Any particular specific topic?
Let me pull up the good first issues tag. So the story about Conda is, if you go to our GitHub page, there is a tag for good first issues. If you're familiar with C Shell, we do have a good first issue to fix Conda support on C Shell. Let me pull up, I'll put the link to the repository. To the list. I mean, there are a number of things that we've identified as good first issue, but I don't remember what they are off the top of my head. Let me see here.
Let me rephrase the question. Forget about the first issue. How do someone who wants to get into, someone who's like fairly a beginner, what would they do? It relates to my initial question, but if I understand Lee's question, then basically, how do I get to communicate with you guys that build all those tools? I want to do this too. How do I? So maybe first issues, but what other ways can I do and communicate with you?
I guess it depends on what you want to do.
I want to be an open source developer. No, I'm not joking. I'm serious.
Right.
Like some people,
So
I think
and
yeah, I think like I'm cool with the idea of just specifically first good issues. But if you're talking about documentation wise, I'd love to know like what do you mean by documentation? Because do you mean like be like rewording things? Like I think what maybe Jacob is trying to get at is like a lot of people like they want to build experience and credibility. That's why they would do some open source contribution, because eventually they would like to contribute maybe with a startup or like a job somewhere. And this is like kind of building up one's portfolio. And Conda definitely is like a prestigious name that everybody knows in the Python and data science community. And it would be a great sort of honor for anybody, especially starting out, to be a contributor for any large project that people have heard of, for skills building and like being a little bit more relevant, like building up to that in the industry. So anything you recommend in that regard?
Yeah. So I think one of the key things, at least we try to recognize, weaving the Conda core maintainers, and then again, like speaking for Conda Forge core and sort of parts of the broader ecosystem, is contribution to open source. It doesn't necessarily have to be code, right? I think that's one of the first things that I think people coming into open source want to jump in and write code. And if you have if you have extensive programming background, that may not be a bad way to start. But for something like the conda ecosystem, right? Like, is your favorite project a conda package? If it's not, go to CondaForge and help them package it up as a conda package. If it is, CondaForge is organized by what's called feedstocks. Look into feedstock and become a maintainer of that feedstock, right? So that would be things like helping update the package, learning how that's built, figuring out like, hey, this feedstock is missing a feature that we'd like enabled. A lot of times feedstocks will have basic, like, how do I use this package thing, sort of issues. That's a place you can contribute. On sort of the tooling side, so on Conda, Conda build, Conda skeleton, Grayskull, Mamba. One of the other things, one of the big things that we need help on more than anything else is issue triaging. Like, if you go look at our repositories, hold on, let me pull this up. We have 1,300 open issues on Conda itself, and I think we have something like 800 open issues on Conda build. Not all of those are necessarily code issues, right? That may be somebody just looking for help. And you can contribute to the ecosystem by just helping your fellow users, right? If you run across a bizarre bug, open a ticket. Better yet, open a ticket and write a test case if you're not sure how to fix it. You know, and then start thinking about how you jump into the code. And then with documentation, you know, you mentioned wording. One of the things that the core maintainers have recognized is our very kind of narrow view of the world in with respect to documentation. And one of the things that we have on our backlog is translation and internationalization of Conda and the ecosystem. And I think that's a good place to help. I mean, we've had somebody offer to translate the Conda documentation to Arabic, right? But I think, again, none of the core maintainers I'm aware of speak Arabic. So for us to move that project forward, we need a second maintainer to step up for that, right? Just so they can check each other. Yeah, I think the way, if you can't contribute code, I think the other way to contribute is basically helping your fellow users and honestly opening tickets, right? I mean, I mentioned our backlog is huge and our ticket log is huge, but one of the challenges we have is we know the number of users we have because we can watch, you know, our network traffic logs. We talk to a tiny fraction of them. Right, and the more we can engage with our user base, the better off the project can be. Fun fact: Conda environment names don't have to use ASCII. So yeah, go nuts. Create random UTF-8 environment names on Windows and let me know what breaks there, because.
So
I'm
I'm falling asleep on the job here, but on the topic of how can I learn to contribute to open source, Gwen has helpfully posted in the chat that the last 2 days of the SciPy conference is devoted to supporting open source software development. So you'll have the core maintainers of the library, possibly Cheng, hanging out on Saturday and Sunday, helping you get sort of on board to the project and finding good issues for you to help out with.
Yeah. I mean, for the Conda ecosystem specifically, we could always use more packages and package maintainers. That's. I think specifically, if you want to engage with Conda, I would say the easiest way to start out is to help me either contribute a new package to conda-forge or help maintain an existing package on conda-forge.
Could you like walk through real quick what that involves to create a new, like to prepare a package on conda-forge?
Yeah, so again, I will refer to, hold on, let me pull up that URL. So generally, the way to add a new package to conda-forge is you create a recipe feedstock. So it's basically a conda recipe for that package, right? Which is essentially a metadata file that specifies the name of the package and the version and its dependencies, and then usually some metadata about things like the license of it, and then a script to essentially, if you're familiar with the Unix build process, to run, configure, make, install. Once you have that, you create, you submit that recipes to what's called the stage recipes repository on GitHub. And that will set up all the magic conda-forge tooling to formally turn that into a conda feedstock, and it will start triggering the CI, conda-forge CI systems. And once that gets past review and gets accepted and merged, you will essentially have a new feedstock and a new recipe, new package and a new recipe on conda-forge. And I'll drop the link in the chat.
Awesome, thanks.
Oh, and some people here will know why we're interested in this, but if you watched Peter's, if you watch Peter Wang, our CEO's announcement at PyCon this year, if anyone here knows WebAssembly, we'd be really interested in talking to you. We being the Conda ecosystem and actually some of our CPython maintainers would be very interested in talking to you. We do have an open ticket to add WebAssembly as a supported package for supported platform for Conda, although we're not quite sure what that looks like at the moment, but ideally, at some indeterminate date in the future, you can Conda install WASM packages, in theory. One thing, just coming back to the contributing to open source question. Let me just share this real quick. So if you look at my GitHub profile, if I can find that tab. Let me just share. So if you look at my GitHub profile, right, like one thing to note is this thing right here about like what I've been doing. I honestly, even as a software engineer on open source projects, don't contribute, like code contributions is a small part of what I do, right? Like only 25% of my open source activity is like actual coding. You know, sort of as a more senior engineer, a lot of it is reviewing other people's code, right? And triaging issues and managing pull requests for various projects I'm in, right? And so that's what I was trying to get at before, is to be an open source contributor doesn't mean that 100% of this spider graph here has to be on the commits end. right? And I know a number of very good engineers whose job are basically like triaging issues in code reviews. And they very, very rarely write code anymore.
Awesome. Thank you, Cheng. Are there any more questions for our speaker? All right, hearing none, everyone, let's thank Cheng for coming here to talk today.
Thank you, Cheng.